I recently wanted to learn Zig and learn to make games, so I started working on a top-down 2D taxi game implemented in the Zig programming language. In the game, you drive around a city, pick up customers, and deliver them to their destination. The goal is to deliver as many customers as you can within the given time limit. Except for the usage of Raylib, I had written everything from scratch, from the entity component system to the physics engine. However, I ran into some problems with the physics engine, where the collision detection basically didn't work properly, and I also knew that it could not handle many more physics bodies in the simulation. I also knew that my ECS system really was just a throwaway piece of code that was going to get replaced sooner or later, preferably sooner. Regarding the physics engine, I looked online for some Zig implementations, but found it rather scarce. There are some C libraries, but I was trying to avoid having too much reliance on C, even though the interoperability seemed to work great. The reason was that I wanted as much Zigness as possible. The only C library I'm using right now is Raylib. I stumbled on some tutorials for making your own physics engine and started watching those. It really inspired me to write my own physics engine, although I wasn't really aiming for something that ambitious. Just enough to be able to run my game without any weird glitches and with a steady FPS. I'm not going to go into details on how I implemented a physics engine in this video. I still need to add some features to it for it to be sufficient for my game, like friction for example. I might do another series where I go through the physics engine though, so keep your eyes open for that if you're interested. For the ECS system, a quick search revealed that there existed a port of an ECS library called NTT, which I was somewhat familiar with. NTT is written in C++ and uses templates heavily to make the compiler do a lot of the work to optimize the runtime. Zig ECS is basically as direct as support can be of Entity to Zig, and uses comp time in the same manner as Entity uses templates. I decided to try it out in a demo project, and it worked really well, so I have now incorporated it into the game engine as well. I also added a basic draw system and some utilities, and the whole package is now the new game engine, which is separate from the game itself. In this video, I will go through the adaptation that was done to the taxi game to use the new game engine. I realize that if you're not familiar with the code in the game, most of the code changes might not be that relevant to you. However, I'm going to go through what I found the most interesting parts of the adaptation, looking at both the libraries being used as well as Zig-specific programming. I started out by first renaming the game from Crazy Taxi to Busy Taxi, and the reason is that there was already a game called Crazy Taxi that I didn't know about. Now the work to adapt to the new game engine can start. I started by importing the game engine, which I call ZGE here, which will probably change in the future, since it simply stands for Zig Game Engine as a working name. I ran into some issues with ZGE not importing the correct modules, so I had to modify the build.zig file in the ZGE project to include those. I then decided to make some changes to my scene type. It had been implemented as a union enum type, but I wanted to try and use an interface instead. So I changed the code that used the scene from switches to just calling the functions directly. I also removed some functions from the game struct that was not needed right now. Now the game struct was basically done, but we'll come back to implement the scene interface later. Previously, I had the screen size be hard-coded in a global constant, but now I wanted to have it in a struct instead, so that you could resize the window and have the screen size updated accordingly. I found a way in the Raylib library to check if the window has been resized, and I decided to just call it every frame and see if we need to update the screen size. You could use isWindowResized together with getScreenWidth and getScreenHeight to get the new size. I needed to make a huge amount of changes to the scene code, and I started by importing the zig-ecs module and adding a new field called reg, which is the ECS registry struct. The registry struct is basically the starting point of zig-ecs. It keeps all components and entities in memory, and you can use it to make queries into the ECS system. Now I need to change all the places where I was using the deprecated state struct and replace it using the registry. In the game, you can pick up customers. The customer can appear at different locations, and these locations are stored in an array called houses. This array was manually calculated in the init function. This could be replaced by a simple view, which is a zig-ecs construct that allows you to easily iterate through all entities that has a specific component. So I opted to create a new component called drop-off-location, and then I could just create a view of that component. Then I could use the view to iterate through all the valid locations where a customer could be spawned. The rigid body component is from the new game engine, and it was going to replace my old components, transform and physics, so I could just delete those. I realized at this point that my new game engine did not have support for having an offset for the collision boxes, so I decided to add that to the rectangle struct. I then started to replace the transform component and the physics component with a new rigid body component. I kept the initialization code for transform component in comments because I wanted to save the scale value. I had not yet implemented the scaling factor into the rigid body, which was something I also needed to do later. I ran into an issue with zig-ecs MultiView here. I could not simply get the number of entities out of the view, as well as quickly looking up an entity by index. The only way I could think of fixing this issue was to iterate through the view and count how many entities we've encountered. Once the length was calculated, I could then generate a random number from 0 to less than the number of entities. After that, I needed to iterate through the entities again until I hit the index that was randomly selected. Stay tuned for the next update where I will go through the changes I made to the scene struct. I converted it from a tagged union into a Zig interface. After that, I will continue to show the rest of the adaptations I did to make the game work with my new game engine. Thank you very much for watching, and see you next time. Bye bye!